I'm your host, Mike Dalka, and I'll be walking you through this. The first thing we're going to do is we're going to put our breadboard Commodore on a piece of foam padding. I like to do that just so that I'm not laying the weight of the computer as directly on the keys. There's a little cushioning there. And I like to use a regular screwdriver to remove the screws rather than a power screwdriver because this plastic can become brittle. So we're going to just remove the screws here. There are 3 screws holding the Commodore together, as well as 3 plastic tabs on the opposing side. So they're at the top. There's the 3 screws. Going to put those aside, make sure we don't lose them. And now you need to carefully disengage the cover here because those tabs are prone to breakage. I'm going to give it a little squeeze back and forth there. The important thing is just that if you feel too much resistance, you stop and then start again. Because these tabs right here, as you can see, those will snap right off and then your Commodore doesn't go back together properly. Now inside we see there's an RF shield and there are a couple of wire harnesses that we're going to have to unplug from the motherboard to get the keyboard out of the way. This first one here is the power LED. I would remove that first as well as remove this dust bunny here. Okay, just pry that off. Sometimes it can be hard to disengage because it's been connected for so long. It's 30 years. Just give it a little wiggle and it'll come off eventually. And the next thing that we need to do then is remove the large harness to the keyboard. You'll see that it plugs in on the far end of the motherboard right here. Now you don't have to worry about marking which way it goes because there is one pin deleted on that plug. It's impossible to install it the wrong way. This is the RF shield. They vary in design depending on what kind you have, but this one is cardboard and it's held on by those 3 screws that I just pointed out. So we'll remove the first 3 screws that hold the motherboard in, and that allows us to slide this RF shield out of the way. It's important to hang on to, so we're going to set it aside and be sure to reinstall it. There's about 4 more screws now holding the Commodore motherboard into the bottom chassis, so we'll just go ahead and remove those. After we remove this, you're going to see on the bottom of this there is another RF shield. On this particular style, it's made out of metal. We're going to have to wiggle this board a little bit to get it out. Just be gentle. There are a couple of connectors that will bind with the bottom of the case. There is that metal RF shield I mentioned. Now this is soldered onto the motherboard, so we're going to have to remove these solder connections. We're just going to set aside the case bottom for later. A few of the important parts of the Commodore 64 motherboard. The first thing is the fuse. That's important to check. They often blow just from age. Doesn't mean there's anything wrong necessarily. These are the capacitors that we're going to be replacing. These are radial capacitors that have 2 wires coming out of one end. There are also a few axial capacitors, these larger ones that have a wire coming out of each end. We also have voltage regulators over here. We have a shielded area for the video chip, and we have the RF output box as well. You can see that the RF box is also connected to that RF shield that's on the bottom, and the shield is connected in several other places as well. We're going to pop this lid off. This is the heatsink that goes against the VIC chip, and it's important that we put that heatsink compound back on. Here's another couple of voltage regulators. These typically don't go bad, so we don't need to replace them. However, you may choose to. So we're going to go ahead and start unsoldering the heat shield now. These are the new capacitors that we're going to put in. We'll set those aside. I will connect my static wristband to the chassis of the motherboard just to be safe. This isn't strictly necessary, honestly, on Commodore 64s unless you're working around the joystick ports, which are known to be static prone. But I'll take this wristband off from time to time just for ease of motion. These are the solder points that we're going to try to remove. I've got a fairly high-powered soldering iron, which makes this pretty easy, and I like to just, those are the connection points there I'm pointing out. I like to just use a small chisel and a hot soldering iron. It's set at about 850 degrees. I'll get the point of the chisel underneath these tabs and then heat up the solder point, and it allows us to just pry back the soldered on tabs from the RF shield. So we'll just take those off very quickly. And now we should be able to free the RF shield from the bottom of the motherboard. Now this cardboard liner is very important on this particular itineration of the Commodore 64. This piece of cardboard is what keeps you from shorting out the bottom of the motherboard against that metal RF shield. So inspect it for holes. If there's any holes that have worn through that could cause the electronics to touch that metal, you're going to want to cover that up with tape. Now what you're seeing is a high-speed version of me removing the old capacitors and putting in the new ones. Now there is a definite positive and negative to this style of capacitor, so you need to pay close attention to how you take them off. Now there's a couple of different things that identify the polarity of these capacitors. There's a long leg and a short leg on most, and the long leg is the positive. Another thing that is usually indicated is the negative will normally be marked. Just be sure to examine it closely. If the capacitor is too small to see clearly, use a magnifying glass like I'm doing in this video to make sure that you install the electrolytic capacitors properly, or else they're not going to work. Now when it comes to identifying the positive and negative side on the motherboard, on the Commodore motherboards, normally the positive is marked with a plus symbol, as well as the solder pad is square, and the negative side will have a round solder pad. Now what I'm doing here is, you'll see I slowed it down a little bit. I'm taking the magnifying glass and I'm looking very closely at each capacitor to make sure that the value that I select is the right one. You can also look at the Commodore service guide that's available on C64show.com to see what capacitor is supposed to be there, because a lot of times Commodore would use a capacitor that was functionally equivalent but might be the same, not be the same as the spec. That can be a little confusing, especially if you've bought a kit to replace all the different capacitors with. So it might be worth checking both things. Check the capacitor you're replacing, and if the value doesn't seem to match up, you can check the specs and see which one Commodore specified and replace it with the proper one. Well, as it turned out, I did not have one of the capacitors that I needed, and so we had to come back to this, and my capacitor arrived in the mail from Mouser Electronics. By the way, sources for all these components, both as kits and individual components, are listed on the website, c64show.com, so let me just plug that one more time. So we're just going to go ahead and install this last capacitor. It turned out to be just a little bit smaller. There are different materials that can be used to make capacitors, and so they're not always the same size. It is an axial capacitor, which was what I needed to fit this board, so that's really not a problem. But if the capacitor is a different physical size, as long as the electrical specification matches, you're okay. I just thought I should point that out, because sometimes in the kits you'll get a capacitor that's a different size, and it doesn't mean it's the wrong capacitor. It's electrically equivalent to the one that was removed, and that's all you really need. Now you can see here I'm soldering both to the top and the bottom of the board. The Commodore 64 motherboard is a two-sided circuit board, and sometimes has connections to both the top and the bottom. I like to solder both. And now we're just going to use some nail clippers to trim off the leads as close to the motherboard as is reasonably possible to do. So now that we have that done, our Commodore 64 is fully recapped, and after testing, we're going to go ahead and start reassembling it. The VIC chip there in the center of the screen has been cleaned off. That's the big black one. I've removed all the heatsink compound from it, and I have reapplied heatsink paste to the metal clip that is attached to the cover that goes over this whole assembly. It is very important to apply this heatsink paste carefully. You need to get enough to do the job, but it's very easy to get too much. And you don't want to do that, because sometimes thermal paste can be conductive because of the metal that's put in it to make it heat conductive. And if that crosses the pins on the chips that the heatsink is being applied to, because you put too much on and it squeezes out the sides, that can short out the chip and either damage the chip or give you some strange reactions. You may notice a voltage regulator off to the side there on the left-hand side of the screen. I didn't like the looks of one of them, so I went ahead and replaced it. So the next step in reassembling is we're going to make sure that our cardboard is there to insulate the RF shield from the bottom of the motherboard, and we're just going to try to wrap those tabs now around the motherboard the best that we can, and we're going to solder these tabs back down. You'll notice that I'm using a pair of needle nose pliers to try and keep the tab down against the motherboard while I resolder it. Now, if your soldering iron doesn't get hot enough to work with that needle nose plier technique, you can just use the tip of a screwdriver or anything small to try to press down on it. And here in just a sec, I'm going to slow the video back down so that you can see what I'm talking about here. Trying to get this last solder connection made to this RF box can be difficult if you don't have a high-powered soldering iron at your disposal. Now there is a trick that you can do to help with this. What happens is that big metal box absorbs so much heat from smaller soldering irons that you just can't get that solder joint to form. If that's the case, what you can do is bare a piece of copper wire and tuck it carefully underneath the lid. Just pry the lid up, and when you snap it back on, trap the wire between the two halves, and then you can solder that to the RF shield. Now that's not strictly necessary, to be quite honest. Most people use the DIN cable anyway instead of the RF output these days, so it's not strictly necessary that you do that. But if you're trying to do a complete job, you might choose to make that connection with a piece of copper wire if you're struggling to get the solder joint to form. Fortunately for me, I was able to add a little solder and get the joint to form, as you can see here. So now we'll just go ahead and finish up the final connections on the motherboard, and then we will have a completely recapped and ready to go Commodore 64 longboard. I've got a few other videos up and more on the way. Check the other videos to see how we disassemble and reassemble the keyboard. Again, I'm Mike Dalka, host of the Commodore 64 Show on Spotify. Thanks for watching. Go to c64show.com for lots more Commodore information and downloads. Hope to see you there.
Mission accomplished. Congratulations.